covered a lot of stuff so far. If you'd like, you can go ahead and study all the stuff, and that would be a great thing. You'd be ready for the midterm. To help you a little bit, I've sorted through all the stuff that we've gone over, and I've picked out what I believe to be the important parts, and that's what I'm going to go over with you today. Now, also, somewhat interestingly, I've made up the midterm. So I know it's on the midterm. Okay? And I can guarantee you that the material that we reviewed today, if you knew it all, you'd be well set up to take that there midterm. So it might be worth your while to, study into what's going on. Good news, all the information that I present to you today should currently be available on campus. Okay? All right, so we're good to go. All right, so let's take a look and see. First part of what we've been studying is all about the process of software development. So, we started everything off about talking about the 5 different steps that go into developing software. It all starts with requirements. You can't develop software if you don't know what your customer actually wants. After you get the requirements, you have to translate it from what the customer is talking about into what your actual software developers can deal with. Then, of course, you have to design and actually write the software. You're not going to be able to have a software product if you don't create the software, right? But you're not done at that point in time. After that comes test and verification. Great, you got some great looking software. Does it do what it's supposed to do? It's got absolutely no idea until I get done testing it. Then, as we talked about, comes the concept of maintenance. And in the great, great world of software development, about 20% of your time is going to be spent creating brand spanking new software, and probably about 80% of your life is going to be spent supporting or changing existing software. So what's a computer? Because hey, if we're doing software, it's got to run on something, right? Well, we talked about exactly what a computer is. So we all know it's a laptop or a server or something like that. It's got 3 basic components to it, right? It's got a CPU, which is basically the brain, the thing that actually processes all the little instructions. It's got the memory, which is where your program gets stored before it gets processed by the CPU. And then it also has a hard drive. And the difference between the hard drive and the memory is the fact that when you turn power off, with a little luck, whatever you put on the hard drive is still going to be there when you turn it back on. However, your memory is considered to be dynamic. So in other words, when you remove electricity from it, it wipes the memory clean. So whenever you turn the computer on, what it does is it looks out to the hard drive, grabs some code, sticks it in the memory, starts to run it using the CPU. Boom. That's all there is to it. Of course, you need to be able to get your input, so you got things like keyboards and mice, and you also have to have some output, so that's why you've got that big honking monitor sitting in front of you. How? That is a computer in a nutshell. Okay, binary numbering system, we know about the binary number system, right? So you and I, when we count, we go 1, we go 2, we go 3, we go 4, we go 5, and we got a unique symbol for each one of those. In the world of the binary system, you only have 2 symbols. Those 2 symbols are a 0 and a 1. That's it. So you can do everything we do with our big old fancy set of 10 digits, 0 through 9, in binary. It's just that it takes more digits to do it, but you only have 2 to work with. So how does that actually work out? Well, we took a look at this. We said, hey, so how do you do a 1 in binary? Well, it's pretty simple. You could just do a 1, okay? But what does that 1 really mean? Well, it's 2 to the 0, which is the number 1. Well, we know all about the power stuff. Cool. So let's do the number 23. So let's think about this for a moment. So is 23 greater than 1?
Yes.
Greater than 2?
Yes.
Greater than 4?
Yes.
Greater than 8? Greater than 16? Greater than 32? So probably want to go right here. So now we know we've got at least 16. So 23 minus 16 is what? 3. What was we saying, 17? So if we do 16, how about another 4? So 16 and 4 is what? So now all we need is another what? Well, that would be what? Maybe a 2 and a 1? And then we'll just fill in some zeros, and we're good to go, right? So 1, 0, 1, 1, 1 is 23, right? We do 65, okay, so we're up here. So 64 and maybe like 1, like that. Fill in some zeros and we're good to go. 128, well, we got 128, right? Okay, let's do that. So I guess 128 right there. Then just a whole bunch of zeros and we're good to go. 1003, well, we go up to 512 here. Next one is 1024. That would be too much. So probably want to be 512 there. Then a bunch of other ones, maybe fill in some zeros, whoop, and we're good to go. Wow. And oh, by the way, if we fill them all in, all ones, we get 1023. which is why the next one's 1024. Cool. Binary, not that hard to do. Yeah, it takes a little bit of thinking just to figure out how it is. But remember, this is the language that that little CPU speaks, right? So you want to speak to a CPU, you do it all in binary. 0, 1, 0, 1, 0, 1. If you can't handle any of your 3s or 4s or 5s. Two main concerns of any software project. Seems like this might be sort of important. What are the two main concerns of a software project? Number one?
How much?
Dollars. Number two?
How long?
Sounds sort of intuitive, right? Hey, I'd like you to write some software for me. Okay, cool, I got some time, I'll do it for you. Cool, two things. First off, what do I have to pay you? And when are you going to be giving it to me? Does these seem like these are critical things to know? So forget everything else in this class. This is really stuff you need to know, right? Cool, alright. Why doesn't the Big Bang work? Where you tell me what you want, I go off to a closet, I write some software, and then I show up a month later and give you the software.
That's what you want to change.
What? You changed your mind while I was off in the closet? So you thought about it a little bit more and said, that's not really quite what I want. What I really want is this. Exactly, right. So you did a lot of work, so congratulations, your time in the closet was well spent. However, you didn't show your customer your work, right? Big bang, big reveal. Oh, hey, here it is. Here's what you asked for, right? You thought that you were doing what the customer wanted, but it turns out, because they changed their dang mind. And now you have to go do what?
Yeah.
Change it. It's all your fault. Okay. What makes a good customer requirement? So it's written from whose perspective? Okay, and we write requirements in whose language?
Computers.
We write requirements in whose language? Exactly. That is 100%. So I'm sorry, what did she say? She wrote it in what? That's fine. What do we call those stupid people what? Who do what to us? Aha! Okay. There we go. Alright. So we write our requirements in the customer's language. We do not write requirements in your language. We don't write them in Python. We don't write them in anything like that. It's all about the customer because it's the customer's requirements. What are user stories? Okay, well, the user stories are, they describe one thing that your software does. Not 12 things, it's not a paragraph, it's not Moby Dick. We're not trying to explain what the whole damn thing does. A user story is it does one specific thing, okay? Written in a language that your customer will understand. Of course it's written in a language your customer understands. Because what language do we write these requirements in? Customer's language, that is exactly right. Okay, should be written by the customer, not you. Yeah, because they like their language. And it should be short. No more than like 3 sentences. We're not going for anything long here. Tell me what you want and do it concisely. Good user stories are not very long. They're not filled with a lot of technical terms. And they don't talk about specific technology that nobody has any freaking clue about. Okay? Makes sense? How do we pick an estimate that's accurate? Remember, we talked about this. We played poker. Remember when we played poker? And some people were over here, and then there was always like 1 or 2 people like over here. Okay, whenever there's that going on, we've got some concerns. Right? Because we've got this gap here. We always have to figure out what's going on there if we've got that big old gap. Somebody's interpreting what's going to be done a little bit differently. What we want to do is get a whole bunch of estimates sort of in the same area. If that's true, then that's fantastic. Then we know we've got a pretty good estimate. If everyone's sort of saying it's going to take roughly the same amount of time, rock and roll. We think that we're pretty good with that. Rules about assumptions. Are assumptions good or bad? Assumptions, are they good or are they bad? Bad. We don't like assumptions, okay? Now, how long should a development cycle take? Those little iteration things we talked about, how long do they run, roughly? They're a month, but it's effectively how many working days? About 20 days. That is correct, okay? If we have estimates that are longer than 15 days, if it's going to take me more than 15 days to do something, what do you think about that estimate? Is it accurate or not so accurate? Not so accurate. People get a little flaky after a while. Now, if you have one of these estimates that's longer than 15 days, what should you do with it? Break it down. Break it into multiple estimates that are smaller than 15 days. You'll probably get a better number if you do that, okay? And you can always go back to talk to your customer and say, hey, what do you really want? Okay? Assumptions are really, really bad stuff. When you're creating estimates, no assumptions is what you want. No assumptions. Okay, assumptions are wrong until clarified by the customer. Remember, if you assume something, well, I assume you'll only use it during the weekdays. Oops, I'm going to use it during the weekend. I assume that you'll stop using it at 5 o'clock. Oops, I'm going to do an overtime sale. I'm going to be using it then. I assume you'll have no more than 100 customers a day. Whoops, you have 200 customers. You make assumptions like that, what's going to happen is they're going to violate it right off the bat. Now, sometimes you do have to end up living with an assumption. Sorry, that's just the way life is, okay? but it's because your customer doesn't know how you can resolve that assumption. Well, when that happens, what you need to do is you need to write it down. And you also might want to delay that user story for a little while, because maybe your customer is going to get more information as you go along in the software development project, and they'll turn that assumption into something that's for real. Problem, too much to do. Oh my goodness gracious, we ran into this one in the time, don't we? Right, I've got 100 days worth of software development, and my customer would like to have it in 50 days. I'm going to think that one, right? Okay? One thing you can do, of course, is to cut out functionality. Look, you know, if I have less to do, I'll be able to do it quicker, right? You can keep your development momentum up by shipping milestone builds as soon as possible. Keep it going, keep it going. And focus on delivering just a working version of the software, which means strip out all the bells and whistles, all the fancy all the interesting cases that you can handle. Just narrow it down to something that works to get it in the customer's hands. Now, one concept or one idea people always have is when they start on a software project is they go, well, I could always add more people. More software developers means it's going to move along faster. Great concept, generally doesn't work out though, because every new person that you add to a project is going to have to get used to the project. They're going to have to understand what's being done. They're going to have to understand who's doing what tools you're using, and how far along you are, and that takes time. They're going to have to understand what's actually being done. They have to understand the technical decisions that you've already made. They understand how everything fits together. And most importantly, what this all comes down to is you add a new person to your team, they are not going to be 100% effective right off the bat. In fact, it might even slow the overall team down as everybody works with them to get them up to speed. So, you know, adding people to a software team that is behind schedule is not a magic cure under the best of circumstances. This is our prioritized example. So we had all of our particular user cases that we had here. We had pay with MasterCard Visa, book packages, arrange travel, book a room, order a DVD, choose a view, all that sort of stuff like that. We had estimates for all these things, but we didn't have any priorities for them. We said, great, with these, what we now want to do is we want to move on and we want to worry about iterations. And remember, we had 3 iterations. Each one of these iterations was how many days? About 20 days, roughly. So what we had to do is we had to go back and we had to say, okay, so this is 10 days, 15 days, 5 days, and 10 days. Let's go ahead and lay it in here and lay it out and figure out how we get all this work done. And we had to sort of say some of the priority 1s and priority 2s, mix them up, and sort of priority all the time. What's velocity? We talked about velocity, right? What is that velocity thing? That's how you're riding your car real fast. What is it? Oh, it can be. That's a value. But what is velocity as a concept? How much work actually gets done? So this velocity is when we work the real world into our estimating process, right? So velocity really says, listen, first off, velocity is a percentage, right? The velocity is how much of your time is being spent doing productive work, right? So it's great to come up with estimates. It's great to fit all this stuff into an iteration, but you're really just talking to yourself at that point in time. When you work velocity into it, what's happened is all of a sudden you've worked in a real-world understanding of exactly how much work a particular software development team can get done in a particular amount of time. Okay? How do you use velocity? Well, you apply it to the amount of work that you have to do in order to get a realistic estimate. Oh my goodness, a realistic estimate of how long it's going to take you. So you take the number of days of work, which is what you have from your estimates, just sum it all up. That's fantastic. You divide it by your velocity, which, you know, a good starting velocity is 0.7. Got no problems with that. And pow. Then all of a sudden you get days required to get work done. So basically what you're doing is you're taking days of work and you're increasing it. Saying, listen, my people cannot be 100% effective. It's just not going to work out that way. So how many days is it really going to take me to do this? So we pointed out that if you have 30 calendar days, it turns out that you only have 20 working days, and if you have a 0.7 velocity, what that really comes down to is you got about 15 days of actual work that you'll get out of a software developer during an average calendar month. Right? Just keeping things real is what we're doing here. Deal with velocity before you create your iterations. So don't make those beautiful iterations unless you've accounted for velocity, because otherwise they don't really mean, you know, the paper they're printed on. Okay? So instead, take a look at the number of developers you have, take a look at the working number of days in your iteration, take a look at the team's velocity, and you figure out the number of person days your team can do in a single iteration. In this particular case, it came out to be 28. Okay? If you work in the number of iterations you're planning on doing, multiply the number of days in a particular iteration, you come up with the total number of days, software developer days, that you have available for your project. Okay? These are critical numbers because these are the ones that really determine exactly how much functionality you're going to be able to work into that software project by the time the customer would like to get it. So how are we going to manage our software development projects? We'll use a software development dashboard to track where our project is currently at. We really want to track three things with the dashboard, okay? First thing is, what work's coming? We're not necessarily working on it, but how much of a backlog do we have? What are people actually working on right now? And, oh, by the way, what kind of work has actually been completed? What's already in the batch? What's already been taken care of? Okay? We'd love to keep this out in public. We want everybody to be able to see it. This is not some sort of secret thing that you hide in your laptop. Rather, this is something that you socialize with everybody who's involved with the software project. This is what it actually looks like. Over on the left-hand side, we've got our user stories with their estimates. As we work on things, we put it in the middle section. If we have to go ahead and delay something, we'll go ahead and put it over here. And when we complete something, we move to the completed section. Up here is our burn down chart. Burn down chart simply shows our progress, okay? So we know at the start of the project, we're here. We know that it's going to take us 88 days to get the darn thing done. And we'd like to get it done in 88 days, so we know that we'd be here at 0 at the tail end because we'd have it all done. And what happens is as we go along, we can actually track how we're doing in comparison to the ideal, okay? We would expect to go a little bit above sometimes, hopefully a little bit below sometimes, but it allows us to see how we're doing and stay on track as we go. Okay? We take user stories, which are actually very, very large pieces of functionality. I would like to have all this work done, and from a software development point of view, we're like, what do you actually want? And we break it up into what we call tasks, okay? So pay with Visa, MasterCard, and PayPal, we break up into pay with Visa, pay with MasterCard, and pay with PayPal. Those are three tasks that a software developer can actually get their hands around. No problems with that whatsoever. Task description should have just enough information to describe what's going on. So once again, we're keeping it short, keeping it very concise. Now mind you, we broke this up into three separate tasks. You take all these tasks together, they account for all of the functionality that's in the user story. Okay? You don't want to lose any functionality as we go there. And oh, by the way, each one of these tasks has its own estimate, and it's entirely possible if you sum up these estimates, it might be different than the estimate that was created for the user story. That's perfectly okay, because once we're hitting the task level, we're getting a more granular view of what's actually going on here. So we would assume that the task estimates are actually more accurate than the estimates that were created for the user story. So going forward, those are the estimates that we should be using. Yeah, we talked about a problem we have when a lot of people work on the same code, right? And generally that's what happens in a large software development environment. When you have a bunch of people working on the same code, what's going to happen is you're going to have the code, and then you're going to have the same developer, or actually different developers, making changes to the same section. Remember we talked about creating frosting and creating candles and all that sort of stuff like that. That causes lots of problems. What's the solution to that type of problem? Well, it's a version control system, right? Some piece of software that allows us to check in and check out software and manages it as a whole bunch of people operate on the same piece of software. Configuration management, version control is a tool, piece of software that will keep track of changes to your files. So how does this actually work? Well, right off the bat, you create a repository. You stick all of your code, if there indeed there is any. If there isn't, then no big deal. You just create an empty subdirectory. You import any code that you currently have into it, drop it in there. Now, going forward, whenever somebody's making any changes to that code, what they're going to do is they're going to check code out of the repository on their little laptop. They're going to make changes to it, okay? And then afterwards, they're going to check the code back into the repository. So the repository is the one place where the master version of all your code is. It coordinates among all the different people who are working on it, and it keeps revision numbers for each version of the code. So if you ever decide to back something out, or if you ever decide to actually drop a feature and say, hey, we're just not going to include that in version 2, 3, 4, or 5, not a problem whatsoever, your configuration management system is going to allow you to do that. It detects conflicts. Remember, if I make a change to a piece of software and you make a change to the exact same piece of software, the system's going to go, oh my God, okay, both of you guys should change the software. You guys are going to have to work out what the final software has to look like. If the changes don't conflict with each other, I change the top, you change the bottom, it says, whatever, it just combines. Okay, if the code can't be merged, then what's going to happen is the second person who checks their code in, they're going to get a red flag. It's going to say, stop. You're changing something that's already been changed. This is way too weird. You work it out and tell me what's going on. Okay? At that point in time, you need to make changes to resolve it. You need to take a look at the code and figure out how your changes work with the other person's changes. You get that worked out, then you resubmit, commit, and you're good to go. Conflict has been avoided. talked about trunks when we're developing software, right? So the trunk is the main line of where all the software is. This is where all the code lives, and this is where you're making all your changes to it. So you start with version 1, you're making all your changes, and now on the other end of your trunk, hopefully you're going to have version 2. Then you make version 3, version 4. By default, your version control software gives you code for the trunk, and that's exactly what you want. When you check out the code, you're checking it out from the trunk, and this is always the latest and greatest code. Now where things get a little bit weird is when you start to make versions. So you come along, you're building software, everything's fine, bam, you decide to give version 1 to the customer. Tag it, call it version 1, you can create a new branch off the trunk, which means that you take all the code that's here, and you copy it down here. Now you'll continue to make changes to your trunk as you march off to creating version 2, but this code will be frozen in time forever. Okay? Always come back. So if you find a bug in version 1, you can fix it in version 1, and you can also go back up and fix it in the trunk and fix it for version 2. Version control summary. So what does version control do for you? Creates a single repository to keep your code taken care of. Allows a whole bunch of people to work on the code at exactly the same time. Keeps track of who changed what. How did that feature get in there? Who gave authorization for that? Keep track of who's doing what. You do branches, you can tag your code, and of course you can always roll back changes. If you decide something's not ready for prime time, you don't want to include it in your code, a configuration management system allows you to pull that change out before you release your software. It doesn't do a whole bunch of stuff. It's not going to guarantee that your software compiles. It's not going to test the code for you. It's not going to even think for you. And it's also not going to make sure that you're checking in good code. You'll take whatever you give it. Here's my pretty poorly documented code. Whatever. I'll just go ahead and stick it in the repository. Build scripts. We talked about build scripts. So remember, you've done all your code. You're happy with your code's fine. Unfortunately, there's 24 more of you. Other software developers out there who are working on the exact same piece of software who've checked all their code in. Time to actually create the big, shiny, final product that you're going to be delivering to the customer. How are you going to do that? So I have to, depending on what language is being used, I have to compile it, your code, and then I have to use your code before I use their code, before I use their code, and then there's some other libraries that I have to bring in, and I have to make sure everything's in the right subdirectory, and so on, and so on, and so on. It can get pretty dang complicated. Now you can do all that stuff by hand. There's no problems with that whatsoever. However, in any sort of large project, that gets to be pretty complicated pretty quickly. And if you're the one person in the universe who knows how to do it, then all of a sudden everyone has to sit around and wait for you to do it before they can have a new version of the code, which isn't so good if they're trying to do their own personal testing. So generally what we do is we create something called a build script, which is basically just a piece of computer code that remembers what you have to do to create that final shiny version of the software, and it automatically goes and does it. It compiles files, it finds dependencies, it packages it all up, and it does a whole bunch of other stuff if you need it to do that. Okay? Build scripts have project, properties, and targets. Projects are basically just the name of it. Remember, you can have one build script per product that you're actually making. Properties are actually almost like variables. Okay? You can give something a value, and then that value is going to be useful throughout the rest of the build script. Target is actually a concept of what you're trying to pull off. Compile means I'm going to be trying to compile all the things. Initialization is perhaps I'm creating all the subdirectories that I'm going to be using for the rest of the thing. And then tasks are where the real work actually gets done. So this one is make directory, and we call it homework_1. So remember, tasks are actually the things that get done during the actual build process. It really doesn't matter what language you're using. There's always a build script for whatever language you're dealing with. It makes your life a lot easier to pull it off. 3 different ways to look at your software. So now you've created your fantastic software. It's not quite ready to give it to the customer yet. Instead, what's going to have to happen, if it doesn't work, nobody's going to use it, and you're not going to get paid, and that's going to make you really sad. So there's 3 different groups of people who have to look at your software. The first group, of course, is your end users, right? And what are they looking for your software to do? What you promised, right? They're looking functionally. They're looking for it to do what it's supposed to do. Okay? The next group, of course, is testers. People who probably work for your company who have one job, which is to test your software. What are they going to be testing to make sure? If it does what you're supposed to do. That's right. They get secret inside information, right? So they're going to double check to make sure it does what it's supposed to do. They're also going to make sure you don't screw anything else up, right? And then potentially other developers might be testing your software. What are they looking for?
They're really looking great.
They're looking for beautiful design, aren't they? Right? And they're diving all the way in. They're taking a look at exactly how you wrote your stuff, and they're going to see if they can hammer it to break it. Right? Okay, so you have 3 different groups. Who does black box testing? Users, right? And what is black box testing? Do you actually get a physical black box? If I was doing black box testing, you look at my desk, would there be a physical black box sitting on it? That would be pretty cool, wouldn't it? Yeah, okay, I'm sorry. So what is black box testing?
You just can't see them know what's going on.
Right. So you just see what goes in and goes out, right? You actually can't see what's going on. And who does this type of testing? Users. Active. Gray box testing. Who does gray box testing? Testers. And what is gray box testing?
They can go in the back and see it, they don't have to read it.
Right. So they can mess around with like the database. They can see if the database is getting checked. They might be able to see parts of your code. More importantly, you can also see what pieces of code are trying to fit together to deliver the functionality, right? Where are those internal interfaces? Because it helps them decide what they actually want to test. And the final group is white box testing. What the heck is white box testing? Full access. I can see your source code, right? Who does white box testing? Developers, right? Your peers, potentially, who are peering at your code, taking a look at it, creating test cases for it. All right. Now, there's also 3 types of testing that get done in the real world. One is called unit testing, and that's the type of testing, test cases that you as a developer create. You know your code, you know what it's supposed to do. You create tests to test your code to verify that it does exactly what you think it's going to do. Cool, fabulous. You then pass it off to system testing. These are done by professional testers. They take your code and a couple other people's code, put it together, consider that to be a system, and then they test to make sure the system works well. If the system doesn't work well, they take a look into it, figure out what's breaking, and they may come back to you and say, your code sucks. Okay? And then finally, there's user testing. Basically, people who are playing the role of the end user, who say, great, this is what we're planning on giving you. Let me run through and make sure it does exactly what it's supposed to do. Congratulations, you're now a software developer.